How you folks doing this fine day? There's the crawler, one of the crawlers. Excuse me. This is Cable Company. I'm Gator, and this is, I dedicate this to the Rocketeers and Tony and Bob Rebels for their contributing to the Apollo mission, and to my girl. She didn't want to be an organ donor, but they made her one. And so, this is for her. This is grandbaby law. Don't forget the reason I'm doing this, okay? Um, this right here is a 2,720,000 kilogram, 6 million pound crawler that transports Apollo Saturn V on its launcher and the mobile service structure. Transporting these structures and the assembly of Apollo Saturn V vehicles from the vehicle assembly building to the launch pad required thorough investigation by the KSC engineers. One mode involved a barge system floating them from the WAB to the pads in a canal. Models were tested in the Navy's David Taylor Basin on the Pontiac River near Washington. These tests disclosed hydraulic problems would be created by a barge large enough to support the vehicle in an upright position. An elaborate launch pad would be needed. So this approach was turned down as infeasible. A rail system was explored. It proved too costly. Pneumatic tired transporters, ground effects machines, and other novel ideas were looked into and discarded. The choice was a track-mounted crawler, resembling in some details the large shovels employed in strip mining, so big that after partial assembly in the plant of Marion Power Shovel Company, Marion, Ohio, it was taken apart in movable sections, shipped to the launch center, and assembled on site. Hydraulic systems were devised for jacking, leveling, and steering. Marion Power won the contract to build 2 crawlers in 1963. Both machines were in service by early 1967. Each weighs approximately 2,700,000 kilograms to 6 million pounds and can transport a mobile launcher with the assembled Apollo Saturn V vehicle at a speed of 1.6 kilometers, 1 mile per hour. A trip to the moon begins very slowly. In event of a hurricane warning, the crawler lumbers up the pad, picks up the launcher and rocket, and carries them back into the vehicle assembly building, all connections intact, to ride out the storm and then return them to the launch pad. Dr. DeBus ordered a surprise test of the capability in 1966 when a storm built up Florida's west coast. Despite winds of 105 kilometers, that's 65 miles per hour, and torrential rain, the crawler returned a launcher and Saturn V to the WAB in less than 12 hours. Hurricane warnings provided a minimum of 24-hour notice. The dimensions of the crawler are the scale with the Paul Bunny adequate portions of the other complex 39 facilities. Each of the 2 machines is 40 meters, that's 131 feet long, and 35 meters, that's 114 feet wide. Equipped with 8 tracks, 12.5 meters, 41 feet 3 inches in length, and 2.29 meters, that's 7 feet 6 inches in width. Each tread weighs 9 metric ton, 1 ton. Despite the ponderous mass, the crawler locates itself at either the launch pad or in the WAB high bay within plus or minus 51 millimeters, 2 inches. A skeptical journalist commented in 1965 that it would never work, but the crawler does work and it works well. 2 identical but independent hydraulic servo systems control the leveling operation. Level sensing and control are initiated by 2 manometers located just under the deck, much like enormous carpenter's spirit levels, with horizontal mercury-filled tubes 41 meters, that's 135 feet long, crossing each other diagonally to form an X. 2 transducers sense errors in leveling and transmit signals to the servo system, which operates two variable control pumps, one for each diagonal axis. The pumps force oil into the hydraulic support cylinders at each corner of the platform to level the chassis and support the entire load. The motion of the crawler, the height and the weight of the cargo, variations in roadway level, the motion of the crawler, the height, weight, and cargo variations of the roadway level, wind, and other factors require stabilizing systems. Steering is performed mechanically. Operator's cab are mounted at both ends, since the operator cannot be behind or on opposite side from his glass enclosed cab. Ground observers walk behind the machine in motion and pass instructions to the cab by walkie-talkie radios. By spring of 1970, when the Apollo 13 launch approached, a Bendix employee assigned to crawler duties reported that he had worn out 3 pairs of shoes, each revealed twice, walking beside the machine on its trips to and from the launch pad. Each crawler had traveled about 563 kilometers, 350 miles in 3 years. 2 double action cylinders at each of the 4 traction units turned the crawler 10 degrees per minute. The minimum turning radius is 152 meters, that's 500 feet. 2,750 horsepower diesel engines drive 4,000 kilowatt generators, which feed 16 traction motors mounted on track drive. 2 more 750 kilowatt generators are driven by 2 1,065 horsepower diesels to operate the leveling, jacking, and steering system. The machine carries 19,000 liters, that's 5,000 gallons of fuel, burning 570 liters, 150 gallons per mile. An automatic lubricating system pumps grease continuously into 176 bearings. 1,900 liters, 3,000 gallons, or that's a 500 gallon capacity radiators help cool the powerful engines. In operation, the crawler moves underneath the mobile launcher and its jacking system engages, feeding under the platform. The launcher is raised off the support pedestals and carried into a WAB high bay and carefully positioned on other pedestals. When the space vehicle has been assembled and tested, the crawler returns the high bay, jacks up the launcher, and carries it to the firing site. The combined mass of the crawler, mobile launcher, and Saturn V, the 5, adds up to 8,200,000 kilograms, which is 18 million pounds. Hence, the roadway which supports this way is quite unlike the normal highway, known as the crawlerway, are 40 meters, 130 feet wide, about the width of the New Jersey Turnpike. Each lane is 12 meters, 40 feet wide, and laid out on a 27 meter, 900 foot or 90 foot center lines. To prepare the base, more than 6 million cubic meters, that's 8 million cubic yards of fill, were dredged from the adjacent barge channel and allowed to compact the subsoil to 95% density, almost the hardness of rock. This project began in November of 1963, and when softer and unsuitable material was replaced with the sand-filled vibratory rollers, leveled the fill, which was proof rolled with a 90 metric ton, 100 ton machine. 2 meters, 7 feet of graded crushed appreciate provided the base course, above which a layer of 30 centimeters, 12 inches of selected hydraulic fill was added. The bed was topped and sealed against moisture with an asphaltic prime coat, being covered by loose Alabama river stone, 20 centimeters, 8 inches deep on curves, and 150 millimeters, 6 inches deep on the straightaways. The loose rock relieves friction on the crawler treads and is occasionally raked over with a spring harrow. The The roadway was completed in August of 1965. It can withstand loads of 58,600,000 kilograms per square meter. That's 12,000 pounds per square feet, or 10 times the resistance of a jet airport runway. Looking like a monstrous turtle, the machine straddles a 15-meter, 50-foot grease medium as it crawls forward. Two sets of trucks on either side of the medium. The operator manipulating a control stick in his cab mounted over the forward truck on the right side. Crawler moves fully assembled Apollo and Saturn V on the mobile launcher from lab to launch pad. There you'll see that right there. Okay. And well, it's a living. Lining the crawlway along the north side are utility and pipeline connecting the web and the pad, while communication and installation lines are buried in ducts below the surface, midway between the control center and the pad A. An extension of the crawlerway veers northeast and connects with the second launch site, or pad B. Close by this junction is another major element of the mobile concept, the 4,800,000 kilogram, 10,500,000 pound mobile service structure. House movers should envy NASA at the spectacular of this 40-story still in moving along a highway on the back of the crawler. The 125-meter, 410-foot tall steel truss tower supports passenger and freight elevators, a power plant, air conditioning equipment, computer, television, and communication systems. Its function is to provide 360-degree access to the upper portions of the Space Beagle for final launch preparation. Assembled as its parking site, 2,100 meters, 7,000 feet from Pad A. The service structure measures 41 meters, 135 feet by 40 meters. That's 132 feet at its base, or roughly half the size of a football gradient. Okay, and it is 34 meters, that's 113 feet square at top. It supports 5 enclosed work platforms, 2 of which are self-propelled, designed to embrace the Apollo Saturn V upper stages. The platform enables technicians to conduct final inspections to load cryogenics and hydrodynamic propellants in the spacecraft, install ordnance items, and prepare the lunar command and service modulars and the launch escape system for flight. The escape system consists of a finger-like rocket mounted atop Apollo, which developed sufficient thrust in an emergency to carry the spacecraft away from the launch vehicle to a scale height of above it. Then the parachute would deploy and lower the Apollo command module into the ocean, where the crew could be rescued by amphibious vehicles or helicopters deployed to the launch area for this purpose. Originally, the service structure was concentrated as a fixed ordnance installation and arming tower to be constructed at Pad A. In 1962, the design was changed to a mobile configuration. Rust Engineers Company finished design work in July '64. Morrison, Knudsen, Fury, Hardiman started fabrication in September, and the structure was completed in late 1966. Since it can be moved, the same structure serves vehicles either at Pad A or Pad B. It is carried to the pad surface by the crawler after the mobile launcher and Apollo Saturn V have been positioned over the flame trench. About 7 hours before launch, at the time when liquid hydrogen propellant is to be loaded into the upper Saturn V stages, the crawler removes the mobile service structure from the pad and returns it to the parking position. The 2 firing sites resemble ancient Mayan pyramids. Pad A is the first to be constructed, was built by Blount Brothers and M.M. Sunday Corp. Between November '63 and October of 1965. From designs from Gibbles and Rosades Incorporated. The same construction built the crawlerway over its 5,500 meters, 18,000 foot length between the WAB and the pad. The critical item which influenced pad design was the size and type flame deflector required for Saturn V. This is a heavy steel device which directs sideward in inverted V pattern the downward exhaust of the 5 booster engines. It was desirable to keep the 111 meter, 363 foot rocket as close to the ground as possible in order to avoid adverse wind effects at higher levels. Consequently, a two-way wedge type deflector weighing 635 metric tons at 700 tons was selected. This allowed positioning the rocket almost immediately about it. The deflector is 13 meters, that's 42 feet high, and 15 meters, that's 48 feet wide at the base. Since the water table is close to the surface, the flame deflector was mounted at the ground level. A trench-lined fire-resistant brick was designed 18 meters, 58 feet wide, and 13 meters, 42 feet high. In turn, this fixed the height of the pad surface. Once the width and the height of the pad was settled, the parameters fixed the width between treads of the crawler, which straddles the flame trench while placing the mobile launcher above the deflector. When construction began, the entire pad area was underwater. Once more, a monumental filling task faced the builders. Dredgers poured more than 3,440,000 cubic consolidated the subgrade surcharge was pumped to the height of 24 meters, that's 80 feet. The resulting multi-level truncated pyramid stood out impressively in the flat terrain. During months following placement of the oversized sand pile, measurements showed that it settled about 1.2 meters, that's 4 feet, and probably compressed the soil beneath. Then part of the surcharge was removed by power machinery to reduce the build to permanent elevation. The launch pad is roughly octagonal and covers about 130 hectares. That's 1/2 square mile. It's centered in the concrete hard stand during launch preparation and mobile launcher. After the Apollo Saturn V on its mobile launcher is in place on the launch pad, the crawler moves mobile service structure to pad. The mobile service structure provides 360 degrees access to the Apollo spacecraft for final launch preparation. And supporting the Saturn V vehicle is secured to 6 mounted mechanism located on the pad surface. The other fixed facilities on the hard stand include a hydrogen service tower, fuel system service tower, and electric power pedestal. Beneath the surface are 4 floors. A terminal connection room housing electronic equipment which is integrated to the communication system connecting the mobile launcher and the firing room in the Launch Control Center, 5.6 kilometers, 3.5 miles west of the pad. Other compartments accommodate environmental control systems, high-pressure gas storage systems, and the emergency express rooms for astronauts or the spacecraft close-out crew. This room is deep inside the reinforced concrete earth revented pyramid and is blast proof. An independent water system was installed to cool the flame deflector. A hydromatic tank of 95,000 liters, that's 25,000 gallons capacity, flows water at a rate of 190,000 liters, that's 50,000 gallons per minute for 30 seconds after ignition. Another water system cools a flame trench and creates a fog-like spray to prevent damage from the engine flames. A reductant pumping system forces the water through high-pressure pipes and nozzles. A 3-second full-up opening of a 91-centimeter, 36-inch valve releases the fudge. About the pad premier are pressure storage tanks for RP1, the kerosene fuel consumed by Saturn V first stage engine. Liquid oxygen at minus 297 degrees Fahrenheit for tanks in all 3 vehicle stages, and liquid hydrogen at minus 423 degrees Fahrenheit, which fuels the second and third stages. Holding ponds within the pad area retain spill fuel and wastewater. There is a borne a burn pond for the disposal of the hydrogen gas boil-off. Stainless steel vacuum jacketed pipes carry liquid oxygen and hydrogen from storage tanks to the pad, thence to the mobile launcher, and ultimately to tanks inside the vehicle. Okay, quantities of fuel and oxidizers are required for each launch. The first stage carries 1,320,000 liters. That's 340,300 gallons of liquid oxygen, and 870,500 liters. That's 215,700 gallons of kerosene, weighing a total of 2,165,000 kilograms. That's 4,744,000 pounds. Second stage tanks hold 334,000 liters. That's 88,200 gallons of liquid oxygen, and 1,032,000 liters. That's 272,200 gallons of liquid hydrogen, for a combined weight of 452,000 kilograms, which is 906,900 pounds. While the third stage contains 75,800 liters, that's 20,000 gallons of liquid oxygen, and 281,300 liters, that's 74,150 gallons of liquid hydrogen, weighing 106,000 kilograms, which is 233,300 pounds. Fuel in the space vehicle requires several days of carefully coordinated operation. The spacecraft is first loaded with the hydraulic propellants, a tanker van carrying 43,500 kilograms, 96,000 pounds of nitrogen tetraride, pulls up beside the mobile service structure, and fuel lines are connected. The oxidizer is transferred at a rate of 227 liters at 60 gallons per minute to Apollo service module tank, which holds 11,340 liters, that's 2,500 gallons. Next, about 227 liters, that's 60 gallons, are loaded into the lunar module ascent and descent tanks and reaction control system. Next day, a tanker of 19,500 kilograms, 43,000 pounds capacity, transports aerosine 50 fuel to the site. Fuel lines connect with a separate fuel distributors in the system of the service structure. About 7,960 liters, that's 2,100 gallons of fuel, are loaded onto the service module, and 4,500 liters, that's 1,200 gallons of lunar module tanks. A separate source provides 380 liters, that's 100 gallons of monothiohydrazine, and 95 liters, 25 gallons of nitrogen tetraride, are loaded into two auxiliary propulsion systems on the Saturn V third stage at the same time the spacecraft was fueled. And I want you to come back and see me, Mitchell Aaron, no senior, 301 Harbor Valley Road, Toccoa, Georgia, 30577. Write me today, tell me what's on your mind, and I'll tell you what's on mine, okay? This is that NASA story. We was talking about the crawler, and I'll go into it and see how much that sucker cost, okay? If you're interested, come on back and see me, all right? Bye-bye.